Hello everyone and welcome to the Day 2 review video. Today we are focusing on sequences and series. As you can see, this is part 1, so let's double check that we're all on the right part. Part 1 is arithmetic sequences and series, so we're going to get started with the review for that. So as a reminder, arithmetic sequences and series change by addition, which means that the terminology associated with that is the common difference. So arithmetic changes by addition. So the way I remember that is that they both start with an A. So not too challenging, but arithmetic is addition. So remembering our formula, I know it's been a while since we've seen it. UN over here, UN is the term we are looking for. So that would be right here. U1 represents, this is U1 right here, is our first term. Notice that the difference between UN and U1, that says first term. I'm going to rewrite that really quick first. Notice that the difference between UN and U1 is that there is a 1 filled in for the N. So that makes sense that it's the first one, right? Because it's the N equals 1 because it's the first term. So N, which we can find right here, N is the term number. So if we are looking for the 11th term, UN would be the value and N would be the term number. So if we're looking for example, the 11th term, N would equal 11 and UN would equal that value. I'm actually going to add up. So term we are looking for, the important thing to remember here is that it's a value. I'm going to add that in really quick. So UN, the value of the term we are looking for, N is equal to the term number. Lastly, D, which we can see over here, is our common difference. And reminder that because this is an arithmetic sequence, this is always going to be in terms of addition. So I'm going to draw a little addition sign next to me over there. Looking to this right panel, this is saying find the sum of the first n terms of an arithmetic sequence. So this is the sum, which means that if we added up all of the terms together in an arithmetic sequence, that would give us the sum of the first n terms. So if we're looking at, this should be in Sn. So instead of UN, notice that this is an S. So this Sn is the sum of first n terms. So again, it's what we're looking for. It's the sum of the first terms. U1, once again, is going to be the first term, which is the same as the last time, except notice that our formula switched a little bit. N is equal to our term number, same as before. N is equal to our term number. And this should not say D. This is going to be, I guess it should say D. That was my bad. So D is going to be our common difference, which again, because this is an arithmetic series, is going to be in terms of addition. So I think the two important things to take away is one, how do we know when to use which formula? Is that when we see a UN like this is associated with the nth term. When we see Sn, that's associated with the sum. So when we're answering questions, that's really important to look and see whether we should be using the nth term formula or the sum formula. And a good reminder is Sn, sum, and S are the same. So that's kind of how I keep it straight in my head. So let's move on to some practice questions. So we have find the 18th term of the arithmetic sequence. So let's label what we know. I know that N is going to be 18. Because I'm looking for the 18th term. So N is going to be 18. My first term is going to be 12 because this is the arithmetic sequence. 12 is my first term. Let's look for the common difference. Right now I don't know that, but I can find that out. So common difference is the difference between these two numbers. So if I'm looking for the difference between 30 and 12, I can subtract my second term minus my first term. So I would take my second term minus my first term, which would be 30 minus 12, which I'm going to go grab a calculator, but we can do that as I'm grabbing it. So if I take 30 minus 12, that gives me 18. So my common difference is going to be plus 18 each time. So I'm going to be adding 18. My common difference is 18. And I do not know what my 18th term is going to be. So when I'm solving for this, I am going to look up, I'm looking for the 18th term. So I know that I am looking for a term number, which means I'm going to use this formula right up here. So rewriting it over here, I have un equals u1 plus n minus 1 times d. I don't know what this is, so I'm going to take u1, which was 12, plus n, which was 18, minus 1 times my common difference, which was 18. So you can put this right into your calculator. That's what I'm going to do now. Hopefully you guys can see that. So I have 12 plus, in parentheses, I have 18 minus 1 times 18. That's weird. My common difference and my first term are 18. And that gave me 318. I'm going to double check that another way just to make sure that I did not lead you guys astray. I also got 318 the other way. Perfect. So this is my final answer. That is 318. If you have any questions, you can pause this video now and call me and Miss Ava over. Otherwise, we are going to look at finding the sum. So a reminder that this one, we are finding the sum, which means I'm going to use this formula. It's still the first 18 terms, so let me fill out what I know. So first 18 terms, that means that n is going to equal 18. My first term is still 12, and because this is the same sequence, reminder, I can find my common difference by taking my second term minus my first term. So 30 minus 12, that gives me 18. That has not changed from over here. So all of my setup information is the exact same. Reminder, I don't think I did a good job of explaining this on the previous one. If I wanted to double check, I could say 12 plus my common difference gives me 30, and that is my second term, so that's a good way to double check that I solved this correctly. But using my formula now, I see it says sum, so I know I'm going to use this formula up here. So I have Sn equals n over 2 times 2u1 plus n minus 1 times d. So let's fill in what I know. I know that n is equal to 18, so I can say 18 over 2 times 2 times, what was my first term, 12, plus n minus 1. N was 18 minus 1 times my d, which was also 18. I can put this into my calculator, which is what I'll do, but that also kind of scares me, so I might condense some stuff down. So 18 divided by 2 is going to give me 9. 2 times 12 is 24, plus 18 minus 1 times 18. I don't know what that is, but I'm just going to say 17 times 18 because I know that that is something else I could do. So now I'm going to put that in my calculator. So I have 9 times 24 plus 17 times 18. That gives me 2,970, which should be my answer. If you have any questions on that one, you can please come talk to me or Miss Avra. Otherwise, this is a great time to pause your video and practice these two questions below. So yeah, the video should be paused. If it's not, I'm just going to keep talking. So we are going to move on to the bottom part. So now we are unpausing the video, and we are going to do one of the problems from our external assessment, which is pretty exciting. These are a little bit more challenging, but they use the exact same skills that we learned above. So I just knocked the button off my lanyard. No cause for alarm. I'll pick it up later. All right. So here we have the first term of an arithmetic sequence. So when I'm reading this, I'm going to box arithmetic because I know that I'm going to be using these two formulas above. An arithmetic sequence is 3, and the 7th term is 33. So over here, I'm going to write that my first term is 3, just because that's some information I'm given. And the 7th term is equal to 33. That was the bell. So hopefully no one will come in and bother us, but you never know. All right, so first term was 3, 7th term is 33. My first question asks us to calculate the common difference. So normally we would take the second term minus the first term and find the common difference. We can't do that here because we only have the first term and the seventh term. So the way I like to do it is to write out the terms that I have. So here I know my first term is 3 and my seventh term is 33. So if I'm trying to calculate the common difference, I know I start with 3, and I know that from here to here, I would add my common difference. From here to here, I would add my common difference. From term 3 to term 4, I add my common difference. From term 4 to term 5, I add my common difference. From 5 to 6, I add my common difference. And from 6 to 7, I add my common difference. So if I start at 3, I have to add my common difference 1, 2, 3, 4, 5, 6 times. So 6 times my common difference to get to my seventh term, which is going to be 33. So once again, I started at 3, added my common difference 1, 2, 3, 4, 5, 6 times to get to 33. Now I just have to solve to get d by itself. So if I draw my line here, we're using SADMAP if that is a familiar concept, but I have to subtract 3 from both sides first. I'm just going to move it over. This cancels out. So I have 6d equals 33 minus 30, or 33 minus 3 gives me 30. I divide both sides by 6, and d equals 5. So I know that my common difference is going to be 5 each time. If I wanted to double check that, which you don't have to, but this is a good skill to have, I would look over here and use my first formula. I know my first term is going to be 3 plus my seventh term I know is 33, so I could say plus 7 minus 1 times my common difference of 5. So I was just going to say this is my check over here. So 3 plus 6 times 5, 6 times 5 is 30, plus 3 is 33. So I know that I did that right. So here and here we got the same number. So I know that I solved for my common difference correctly. Again, you don't have to do this over here. This is a way if you want to double check your work. So moving on to part B, we have calculate the 95th term of the sequence. So if I'm looking for the 95th term, I know that I'm going to use the formula with UN because this is a term that I am looking for. So UN is what I do not know. My first term is 3 because they told me that up here. My common difference is 5 because that's what I calculated right here. And N equals 95 because it told me right here that I'm looking for the 95th term. So I have all of my elements here. So I'm going to go back to the top left of my notes. And I know I'm working with the formula UN equals U1 plus N minus 1 times D. So UN is what I don't know, so let's fill in what we do know. U1 is equal to 3 plus N minus 1, N is 95 minus 1, times my common difference of 5. I'm going to put that right into my calculator, if it turns on, which it did, great. So I have 3 plus 95 minus 1 times 5. And that gave me 473. So if you have any questions, please come talk to me or Miss Avera. Otherwise, we are going to move on to part C. There's the second bell. So we're going to calculate part C. So it says calculate the sum of the first 250 terms. So I know that the sum, that means I'm going to use my formula at the top right because I need to know the added total of all the numbers together. So once again, I'm using my same sequence I have in my whole time. That means my first term is 3. That means that my common difference is going to be 5. And that means that my N is going to be 250 because I'm looking for the sum of the first 250 terms. There's someone trying to get in the door. We almost made it, team. But I'm going to rewrite the formula I'm going to use, which again you can find at the top right. So the sum of the first n numbers is equal to n over 2 times 2u1 plus n minus 1 times d. So let's fill in what we know. So sum of the first 250 terms equals n, which is 250, over 2, because that's in the formula, times 2 times my first term, which is 3, plus n, which is 250, minus 1, times my common difference of 5. And that should put us in pretty good shape. Once again, you can put this right into your calculator. I'm going to condense it a little bit because I get nervous about my calculator skills. So I'm going to say 250 divided by 2 is 125 times 6 plus 249, which is 250 minus 1, times 5, which is 1,245. So we have 125 times 6 plus 1,245. This is how I'm typing it into my calculator. And that gives me a total of 156,375. So if you have any questions, please come talk to me or Miss Avra. Otherwise, please stop and work on some of the other problems on the You Try section, which are all from, again, the external assessment. So now it is time to pause and practice the rest of the time on arithmetic sequences and series. Moving on now, we are going to move into the geometric sequences and series portion. So everything we just did with arithmetic still can help us, but now we are using geometric. So geometric sequences and series change by multiplication, which means that our term for the changing is the common ratio. So geometric sequences change by multiplication. Remember that our common ratio should always be in terms of multiplication. So looking here, find the nth term of a geometric sequence. So the nth term is associated with un. So un is equal to the term we are looking for slash the value of the nth term. So it's normally the term we're looking for, but technically it is the value of the nth term. Moving on, u1 is the same as last time. u1 is equal to my first term. N is again the same thing as last time. N, reminder that is in our exponent up there. N is equal to the term number. And R is equal to our common ratio, which is again the amount that our sequence is changing by each time, and that is in terms of multiplication, or this, if that's helpful. So this is multiplication. Over here we have the sum of the first n terms of a geometric series. So instead of un, again this should be Sn. Sn is equal to the sum of the first n terms. Reminder that first n terms is just the first however many terms, so first n terms. u1 is equal to the first term. Reminder, un is right up here in our numerator. N is equal to the term number. And R is once again equal to our common ratio, which is again in terms of multiplication. The common ratio is the amount that we are changing by each time. So if it is over here asking us to find the 11th term of the geometric sequence, we are going to use this formula up here because we are looking for, this nth term formula. So the 11th term is a numbered term, right? So I know I'm going to use this equation. So let me write that down really quick. We have un equals u1 times r to the n minus 1. So let's fill in what we know. We don't know what the 11th term is. That's what we're looking for. I do know that u1 in this case is equal to 1.5 because that's my first term. I know that I am looking for the 11th term because it tells me that in the problem. So what I have left is my common difference. So a reminder that with arithmetic sequences, to find our common difference, which I'm not looking for, I'm looking for my common ratio. With arithmetic sequences, to find my common difference, I would subtract my second term in my first term. Here, I'm working with multiplication, So what's the opposite of multiplication? I'm going to cross this out right. What is the opposite of multiplication? Division, right? So I can take my second term divided by my first term. So that would give me 3 over 1.5. This is my second term. This is my first term. So my second term divided by my first term, and that will give me my common ratio. So if I take 3 divided by 1.5, that gives me 2. So I know that my common ratio is going to equal 2. How could I double check that? If I look at my first term, that is 1.5. So 1.5 times my common ratio of 2 should give me 3. If I do this again, my 3, which I have from above, times 2, my common ratio again, should give me 6. So I just double checked myself twice to figure out that I was right. So I know that my common ratio is equal to 2. So now if I'm filling in my numbers, I see that my first term is equal to 1.5. My common ratio was equal to 2. I'm looking for the 11th term, so I'm going to say times 2 to the 11 minus 1. I'm going to show you guys on my calculator again because it can be a little bit tricky. So I have 1.5 times 2. Reminder to hit this exponent button right here because the n minus 1 is in the exponent. So times 2 to the 11 minus 1. That should give me an answer of 1,536, which would be my answer. So the 11th term is going to be equal to 1,536. Moving over here, it says find the sum of the first 11 terms of the geometric sequence. It's the same sequence, so I know that my first term is going to be 1.5. I know that n is going to be 11. And I know that my common ratio is going to be 2 because that's what I found over here, and the sequence is the same. The only difference is that it tells me I'm looking for the sum. So I know that I'm going to use this formula here because it tells me I'm looking for the sum. So I know I'm going to use the formula Sn equals u1 times r to the n minus 1 over r minus 1. And notice I already have all the information I need. So if I'm going to fill it in, I am going to set up my fraction bar first because that helps me to keep track of what I'm doing. My first term is 1.5 times r, which is 2, to the n minus 1. N is 11, so it's 1.5 times 2 to the 11th power minus 1, over r, which is 2 minus 1. So I can put that right into my calculator. If I'm looking here, I would set up my fraction bar first and say 1.5 times 2 to the power of the 11 minus 1 over 2 minus 1. That gives me 1,536, which u1 times r2. That would happen here because notice that 2 minus 1 gives me just 1, so I'm basically dividing it by itself. Oh, you know what I did wrong? This is actually a really good thing. So notice here that it's r to the n minus 1. This minus 1 is not in the parentheses. So it's 2 to the 11th minus 1. So this is wrong. Do not do this. What we need to do instead, we had a lot of trouble with this, I remember. I still do, clearly. It's 1.5 times 2 to the 11th, and then we need to get out of that exponent to get to the minus 1. So again, 1.5 times 2 to the 11th minus 1 over 2 minus 1. So once again, notice that that minus 1 is not in the exponent. That would give me 3,070.5. So that is our actual sum. The other way, if we do it like this up here, we're going to get the same answer as above, which is incorrect because we want that minus 1 to be out of our exponent. So the answer here is 3,070.5. So this is the answer we should be getting, 3,070.5, which is this one right here. Good. Now is the time to pause and practice. So take some time, solve these two below, figure out which formulas we have to use before we move on to this one, which is right here. So if you have not paused and practiced yet, now is the time that we're going to go here. So let's work on this problem from the external assessment together. So the 7th term of a geometric sequence is 108. I'm going to write that off to the side. The 7th term of a geometric sequence is 108. The 8th term is 36. So it says write down the common ratio of the sequence. So if I were to write this out, 1, 2, 3, 4, 5, 6, 7, 8, I would know the 7th term is 108 and the 8th term is 36. So even though I don't know all of these, I know these two are right next to each other. So if I'm finding the common ratio, I know that the common ratio is what I multiply by to get from this term to this term. So I could say that 108 times my common ratio equals 36, and that would allow me to solve for that. So how do I get r by itself? I'll divide both sides by 108. So r equals 36 divided by 108, which gives me 1/3. I'm going to turn that into a decimal. So go to menu, to number, 1, convert to decimal. R equals 1/3 or 0.333. I'm going to keep it as a fraction just because I like fractions better, but you do not have to. So R is equal to 1/3, which is good. How can I double check that again? Well, if I start at 108 and I take 108 times 1/3, that gives me 36, so I just double checked my answer. So here, it says find U1. So there are two ways I can think of to do this. If I have to multiply by the common ratio to go this way, I could divide by my common ratio all the way back until I get to the first term. So I could take 108 divided by 1/3 divided by 1/3 all the way back. That is perfectly valid. That seems like a lot of work to me. So what I'm going to do is set up my equation. So I know that I'm going to use the formula UN equals U1 times R to the n minus 1 because that makes sense to me. I'm going to fill in what I know. So I know that R is going to equal 1/3 because I just solved for that above. I do not know what my first term is, right? I have no idea. Do I know what UN is? Well, they give me 2 right away. So if I look at here, if I say that UN is equal to 36, what does n have to equal? 8, right? Because I know that the 8th term, that's an 8. I know it's kind of hard to tell. This is an 8. So the 8th term is 36. So I can use the fact that n equals 8 and the nth term equals 36 and solve this way. So then if I'm filling in what I know over here, I could say what does UN equal? 36 equals U1, which I don't know what that is, times R, which is 1/3, to the power of n, which if I'm talking about 36, that is my 8th term, minus 1. So if I solve this, I say 36 equals U1 times, let me plug this into my calculator. So I know that this is 1/3 to the power of 8 minus 1, which is going to be 7. That gives me 1/2187. How do I undo that? Well, this is dividing, right? This is saying U1 divided by 2,187. I can multiply both sides by 2,187. This will cancel. So U1 equals 2,187 times 36, which is a really big number, I know, but this is correct. So we have 78,732. That is my first term. That also makes sense logically, right? Because if I'm thinking about if I had to multiply by 1/3 each time, and my 7th term is still 108, that's going to have to be a pretty big number. So I'm feeling pretty confident about that one. The next one tells us to find the 15th term. So let's think about what formula I should use. If it asks me to find the 15th term, I know that I'm going to use this formula because I'm looking for a certain term number. So if I'm looking for the 15th term, my UN is what I don't know. My N is going to equal 15 because that's the term number I'm looking for. My first term is what I just solved for above, which is 78,732. And my common ratio is 1/3, which I also solved for above. So I'm taking my answers from part A and part B and using it to answer part C. So if I'm setting up my formula, I know that UN equals U1 times R to the N minus 1. I don't know UN. I do know that U1 equals 78,732 times R, which is 1/3, to the N, which is 15, minus 1. I'm going to pop that right in my calculator. Hopefully you guys can see this. It just turned off, of course. So we have 78,732 times 1/3 to the power of N, which is 15 minus 1, which gives me 4/243. If I wanted to convert that to a decimal, I could, and it would be 0.016. So I'm going to write both. So 4/243 or 0.016. So my two answers can be found over here in the corner. Moving on to our last one, so exciting. We have find the sum of the first 7 terms. So find the sum. So if I'm thinking about the sum, I know that I'm going to need to use my formula at the top right, which is Sn equals U1 times R to the N minus 1. Reminder that minus 1 is not in the exponent, which is a mistake I already made, divided by R minus 1. So if I'm looking for the sum of the first 7 terms, I know that N is going to equal 7 because that's how many terms I have, my term numbers. I know that U1 is still 78,732 because that's what I found up here. And I know that my common ratio is still 1/3 because that is also what I found up there. So if I plug in everything I know that U1 is 78,732. I know that R is 1/3 to the power of 7 because that was my N minus 1 over R, which was 1/3 minus 1. So this time my denominator is not going to just be 1. So over 1/3 minus 1. This is going to be a doozy, so I'm going to set up my fraction bar ahead of time. I have 78,732 times, I'm going to set up another fraction bar, 1/3 to the 7th. Okay, so look, I tried to even put that to the 7th power inside my calculator. Notice how it's outside. I need to go back to the front and set up another parentheses because it's 1/3 to the 7th power minus 1. So see that this 1/3 to the 7th minus 1 because I need to distribute this multiplication across both. So I need to make sure if you're set up a fraction bar like me, like this, that we have another set of another set of parentheses after that minus 1. So make sure that your numerator looks like this. And I'm going to divide by 1/3 minus 1, which we can see is in my numerator down here. I'm going to hit enter. That gives me, oh man, 118,044. 118,044. I'm going to scooch over my thing. 118,044, which is my correct answer. Because, and that makes sense, right? Because if my first term's already 78,000, I'm going to have a pretty big number if I'm looking for the sum of the first 7 terms. So 118,044, that would be my final answer. This is the last time to pause and practice. If you have any questions about anything, please call over me or Miss Avra. Otherwise, you guys are on your own, and thank you for sticking with this Google Classroom video.